Hello, this is a lesson on using scale factor. Our learning goal is students will explain how to enlarge or reduce a figure by using scale factor. Enlarge means to make bigger, and this word reduce means to make smaller. Now, scale factor is a ratio. This ratio compares the corresponding sides of a figure. By corresponding sides, this is what I mean. Let's say I have this figure. I'm going to enlarge it by a scale factor of 3. So I'm going to start with this side. I'm going to call this side 1. And that means 1 times 3 is 3. So this side of my corresponding figure is 1, 2, 3. Now I'm going to enlarge this side. This side is also 1. So I'm going to enlarge this by 3. 1, 2, 3. This is my last corresponding side. It's the bottom side. This is 1. I'm going to enlarge this times 3. 1, 2, 3. Now my figure has been enlarged using this scale factor. That's my scale factor. I called this one the original, and I called this one the copy. I could also call this one the old one, and this is the new one. So the ratio I'm looking at is the size of the copy to the original. I could also say the size of the new one to the old one. In this case, my copy is 3 times as large for my green side as the original, which is 1. That's my scale factor. So basically, to use scale factor to enlarge a figure, I multiply the original sides of a figure by the scale factor. That gives me the size of the copy sides. Now I'll do an example. I draw a figure. I'm going to use different colors for each of the sides. This time I think I'm going to do a quadrilateral. Now, using dot paper is a little tricky. So I don't count the dots, I count the spaces in between. So this is 1, 2. The length of this side is 2. A common mistake is for kids to count the dots. Then they would go 1, 2, 3, and they would call this side 3. That's not true. We count the spaces in between. So this is 1, 2, 3. Now honestly, I don't know what this length is. It's not connecting the dots, it's going diagonally. Its length is a square root, so we're just going to put a question mark on that one. And then finally, this one right here, 1, 2. Okay? So I'm going to use a scale factor of 3. Use SF times 3. So this is my original, and now I'm going to make my copy. So I have 2 times 3 would be 6. 6. So I'm going to go 6. So 1, 2, 3, 4, 5, 6. I might run out of space up here. I should have I'm going to move this to a different place. I think I will run out of space, so I'm going to do it down here. So 1, 2, 3, 4, 5, 6. And now my blue line, the bottom line, is 2. So again, that's 2 times 3, so that's also going to be 6 across. 1, 2, 3, 4, 5, 6. And my green one times 3 will be 9. So I'm going to start here, 1, 2, 3, 4, 5, 6, 7, 8, 9. Kind of overlap there, whoops. And my purple one, I don't know how long it is, I'm just going to connect those dots. That's okay. So I've just used a scale factor to enlarge my figure. Now I could also do the opposite thing. I know this is 9. I know this is 6. And I know this is 6. I can reduce this. Now this is my copy. Okay, but I can reduce this now. I can make another copy. I can pretend this is my original. And I can reduce it by 1/3. That would make it smaller if I use a fraction. So I can reduce this by 1/3.